Okay, so you've recently learned how to count atoms. I just want to do a little recap, okay, on counting atoms. So let's say we have a water molecule. Let's say we have a carbon dioxide molecule. Okay, all a molecule is more than one atom bonded together. So here we have hydrogen and we have oxygen. This is a subscript, and this tells us how many atoms. So hydrogen has 2 atoms in this molecule. And this oxygen, there's nothing here, so there's an imaginary 1. So there's only 1. There's a total of 3 atoms here in this molecule. In one water molecule. So over here, for carbon dioxide, we have carbon and we have oxygen. Carbon, there's an imaginary 1 here. There's only 1. There's a subscript here, so this means oxygen, there's 2. For a total of 3, there's 3 atoms in one carbon dioxide molecule. All right, let's do one that's a little different. Okay, this is going to have a coefficient. This is iron oxide. So this is the molecule. And this number up front tells us how many molecules. This is a coefficient. Coefficients are different from subscripts. Subscripts are lower, and they tell us how many atoms. Okay? Subscripts tell us how many atoms of this kind. So because this subscript is right next to iron, it's telling us there's 2 atoms of iron. Okay, this one's lower, 3 atoms of oxygen. Okay, so let's write this out. We have 2 atoms of iron, and oxygen we have 3. Now because of this coefficient, we're going to multiply this by 2. If this wasn't there, that means there would be, that's 1 molecule, and so this would be fine. But this means that there's 2 molecules. Okay, so everything's doubled because there's a 2 in front of it. So because there's a 2, we're going to multiply. 2 iron atoms multiplied by the coefficient 2 means that there's now going to be 4 atoms of iron. 3 times 2 means that there's 6 atoms of oxygen for a total of 10 atoms. Okay, let's do another one. Let's use parentheses. Let's do a calcium chloride. All right, so we don't have a coefficient, we do have a subscript, and the subscript is right outside these parentheses. So the subscript belongs to both of them. Okay, so that means this 2 means there's 2 oxygen. This 2 means that there's 2 hydrogen. So let's write out what elements we have. We have calcium, we have oxygen, and we have hydrogen. There's an imaginary 1 here, so we only have 1 calcium atom. We have this 2, this subscript 2, right outside these parentheses, and that 2 belongs to the parentheses, so it's 2 of everything inside of it. So 2 oxygen atoms and 2 hydrogen atoms for a total of 5 atoms. Alright, something new here. Let's start talking about chemical equations. Equations means that there's something equal to something. The word equal is there. Okay, so there will be an equal sign. That means something in front of it equals something behind it. But we're going to be talking about chemical reactions, so we're going to be talking about chemical formulas. Chemical formulas. So in a chemical formula, usually the equal sign will look like this. This gives you, or this tells you that there was a chemical reaction. And if you guys remember, chemical reactions means that something was turned into something new. Well, what was before, like the 2 plus 2, here, these are called reactants. Okay, and what we get after the chemical reaction, which is like what this 4 would be, this is the product. Okay, so before we get into an equation, I want to remind you of some molecules and their formula, because we're going to be using them. Okay, you guys might remember these from last year. Hopefully. This one we have, this is one molecule of carbon dioxide. This is one molecule of glucose. This is one molecule of the type of oxygen that we breathe. And this one, you know this one, this is one molecule of water. And I want to remind you of photosynthesis. You've talked about it many years in school, since you were in elementary, and I know we talked about it last year. Photosynthesis is a process. Something is happening. And what's actually happening is a chemical reaction. And what is fueling this chemical reaction, what fuels the process, is the sun's energy. The sun's energy, it's the fuel. Like, in order to make your car run, you need fuel. For it to work or do anything, you need some kind of fuel to get it doing its thing. Well, this is a process that needs fuel from somewhere, and that fuel comes from the sun. The sun is not a molecule. It is not, this is not going to be something that was a reactant or a product. It's just something that fuels the whole process. And if you guys remember, this process happens in the leaves of our plants. Okay? We have, and this is why we needed to remember this up here. If you guys remember, we have carbon dioxide that we exhale. We breathe it out, and other animals breathe it out. It needs carbon dioxide, and it also needs water. Okay, then the magic happens, the chemical reaction happens in the leaves, in the chloroplast actually, if you remember that. And what the products are, oxygen gets released into the air for us to breathe, and then we also get sugar, glucose. So let's look at this in an equation. Okay, let's look at this in an equation. And just so you know, because we didn't talk about this last year, in order for this process to happen, the plant needs 6 molecules of carbon dioxide, 6 molecules of water in order for this process to even happen. And then after the chemical reaction occurs, we wind up with 1 molecule of glucose and 6 molecules of oxygen is released into the atmosphere. So let's look at this as in an equation form. So we have our reactants, 6 carbon dioxide, and 6 molecules of water, fueled by the sun. Okay, this is the radiant energy, the sunlight. That's fueling the process. And what we have as products after the chemical reaction is 1 molecule of glucose and we also get 6 molecules of oxygen. Now let's count atoms. Let's use what we learned earlier this week. This, I just want to remind you, is a coefficient. I want to remind you that this is a subscript. Okay, and so subscript tells us how many atoms, the number of atoms. A coefficient tells us the number of molecules. That's what that tells us. So let's take a look. Let's first write down what elements we have, or what type of atom. We have carbon, oxygen, hydrogen, and then oxygen again. Okay. So let's not think about the coefficient just yet. Okay. We have 1 carbon atom, 2 oxygen. Okay, now let's look at the coefficient. So we have 6 of these molecules. So let's multiply these by 6. So we have 6 carbon, 12 oxygen. Okay, so that's that one. Let's work on this one now. Okay, let's not look at the coefficient just yet. We have 2 hydrogen, and we have 1 oxygen. And we can add these together in a minute. So now let's look at the coefficient. Okay, so multiply by 6 because we're talking about 6 molecules here. 6 times 2 is 12. 6 times 1 is 6. So let's simplify this. We have 6 carbon atoms. I'm going to do the hydrogen. We have 12 hydrogen. And then we're going to add these 2 together for the oxygen. We have 18 oxygen. That's how many atoms we're starting out with before the process. So let's see how many atoms we have after the process. Okay? So this is a chemical reaction. So let's see what we end up with. Okay, we have 6 carbon, 12 hydrogen, 6 oxygen. Not bad so far. Okay, now let's look at this one. Let's not worry about the coefficient just yet. Okay, we have 2 oxygen. There's 6 molecules, so times 6, that's 12. Okay, so let's simplify this just like we did down here. Okay, we have 6 carbon, 12 hydrogen, and then let's add these 2 together for oxygen. We have 18. Ooh, let's see. That's equal, that's equal, that's equal. Okay, so what the atoms in the before the chemical reaction is going to be the same amount of atoms after the chemical reaction. And this has a name. This is called the law of conservation. Okay, and what this is saying that in a chemical reaction, matter is not created or destroyed. It's just rearranged. It's just rearranged. So we took atom arrangements, rearranged those same atoms into different molecules.